Okay, so this is the end of the Cavin cycle, and most of the people really find it hard to do this because there are a lot of enzymes involved. There are a lot of, things to memorize. Let me tell you, how can you memorize all these enzymes? Okay, the first thing is an enzyme always ends with A's. If you have something called A's, then it's an enzyme. You have to remember that. So if you have something ending with A's, this is an enzyme. So you see there are a lot of enzymes involved in that. So what I'm going to tell you the entire overview. So this is going to be about how you remember the enzymes. This is going to be about enzymes. So how do you remember all the enzymes? That's what I'm going to do. So in the first step, we use an enzyme called aldolase. And what's the function of this enzyme? So the first step involves, I think I've told you the first step. The first step involves the the conversion of this into this. Converts glyceraldehyde 3-phosphate into dihydroxyacetone phosphate. Okay, so this aldolase is used in this, and also triphosphate isomerase. Because you see these two are isomers. If you actually look at the structure, I mean, where is that? I mean, somewhere over here, I guess. Yeah. So this is the structure of G3P. This is the structure of DPAH. If you actually look at them, they're both isomers because they have 1, 2, 3, 4, 3 carbon atoms. It's got 3 carbon atoms. CH2. It's got 1, 2, 3, 4, 5. 3, 4, 5 hydrogens. It's got 1, 2, 3, 4, 5 hydrogens in this phosphate group. If you actually see, they're both isomers. Okay, they're both isomers. So this is basically isomerization. We're converting one isomer into another isomer. You understand that? So so that's why if you're actually doing the isomerization, we actually use this enzyme, isomerase. If you find an isomerase, then you're actually doing the isomerization. And this isomerization happens with triphosphate. You see that? It's just it's not triphosphate, it's triose phosphate. I'm sorry about that. This happens, this enzyme converts a triose phosphate. You see, this is a triose phosphate because you have 3, where's that? We have 3 carbons, and this is a triose phosphate. We're converting a triose phosphate into its isomer. That's why it's called triose phosphate isomerase. Okay, all right. Then we use another enzyme called transketolase. So what happens? This enzyme basically breaks up. It removes 2 carbon atoms. So what's the function of this enzyme? So I'm going to tell you what it does. It does removes 2 carbon atoms, and what is its specific action? So this basically breaks the 2 carbons from this chain. So this transketolase, it's a very important enzyme. And we did basically, what we did, we took EGP, we reacted it with cetoheptose 1,7-biphosphatase. So this is an enzyme which converts it into cetoheptose 1,7-phosphate. So when you have A's as a suffix, it means it's an enzyme. Okay, you have to remember that. So so before doing this, we did a conversion. We took aldolase and fructose 1,6-biphosphatase, and we converted this into fructose 6-phosphate before doing this. So it's over here. So this is what we did. we convert it into fructose 6-phosphate. Okay, so this fructose 6-phosphate again is removed. 2 carbons from this is removed, and this forms erythrose biphosphate, and this is done in the presence of trans ketose. So when you have an enzyme trans ketolase, it basically removes 2 carbons. That's what it does. Removes 2 carbons from this and gives it to this G3P, and it gives it to G3P, which actually forms xylulose 5-phosphate. And this again appears when this cetoheptose over here, this cetoheptose is broken down by trans ketolase again into ribose, and simultaneously this cetoheptose is broken down by trans ketolase. These 2 carbons are removed from this cetoheptase to form ribose 5-phosphate, and these 2 carbon atoms are added. So these are added to 2 carbons. Let me write it down. 2 carbons are added to G3P, glyceraldehyde triphosphate, 3-phosphate, to form. So this guy actually forms pentoses. Okay, so this actually forms xylulose again, xylulose 5-phosphate. Okay, so what this trans ketolase enzyme does is it actually takes 2 carbons away from this any larger molecule, and it gives it to glyceraldehyde 3-phosphate. So that's what it does. So that's the summary of the important enzymes used. And another important enzyme used is aldolase. This is also another important enzyme. So let me write down the list of the enzymes we used. So over here, let me write it over here. So let me write down the list of the enzymes used. So first, we used aldolase in step number 1 and 3. This aldolase is used to. So let me write it down. So let me write down all the enzymes used right there. So all the enzymes used was, the first enzyme used was triose phosphate isomerase. So this is an isomerase enzyme, and there's also another isomerase enzyme we used somewhere. I don't remember that. Okay, so let me write down all the enzymes. Maybe I'll strike me suddenly. All right. So the next enzyme we used was fructose 1,6-diphosphatase. So this is one enzyme we used. So remember how we used this enzyme? We converted it into fructose phosphate. Okay, fructose 6-phosphate. That's what we did. Converted what? Converted this what do you say? G3P and DHAP to form that. All right. So we use it converting this into fructose into F6P. So next, if you remember, we have converted this F6P back into cetoheptose, and we did it by using aldose enzyme plus